Okay, today's topic is the unit circle. Now, you may have heard of the unit circle, and the unit circle is known as the unit circle because it has a radius of 1. Now, this is the unit circle as it's commonly used in trigonometry. It's not filled in. You can look online, and these things are out there all over the place, and you can just copy these numbers in if you want because it's no secret what they are. But what do they mean? Well, before we fill in the unit circle, and that's going to be your job for today, your assignment, we're going to talk about what the unit circle is. And, I saw that some of you don't have a printer. Well, you can make your own unit circle. But, and I'll show you how to do that. But before we get to that, we're going to talk about what the unit circle is. All right? And to start with that, we're going to go back to these two triangles that we know. The 30, 60, 90 triangle, which has sides of 1, 2, and square root of 3 that we've talked about before, and the 45, 45, 90 triangle that has sides of 1, 1, square root of 2. Now, believe it or not, the unit circle incorporates these things. And they show up all over the unit circle with the hypotenuse is going to be these sides. But remember, keeping in mind the unit circle, if it's a circle, the radius is 1. Well, this has sides of 1, but not the hypotenuse. So what we're going to do is we're going to create similar triangles to these two that have a hypotenuse that has a side of 1. Well, this one's pretty easy to deal with. All we have to do is divide everything by 2, and we have a similar triangle to this one, which is 30, 60, 90 triangle. It has a side of 1 here. Divide that by 2. Divide this one by 2, and I got 1/2. And divide this one by 2, and I have the square root of 3 over 2. That is a 30, 60, 90 triangle every bit as much as this one's a 30, 60, 90 triangle, but it has a hypotenuse of 1. And similarly, we can create a 45, 45, 90 triangle that has a side of 1 on its hypotenuse by dividing everything by the square root of 2. All right, I'm going to divide this side by the square root of 2 and divide this side by the square root of 2. This triangle is a 45, 45, 90 triangle with a hypotenuse of 1. Now, we've talked earlier about rationalizing that to the square root of 2 over 2. And you can go back and review how to rationalize. All right, so these will be used in the unit circle to find values of sine and cosine for all of the angles. For example, let's just look at this one right here. Looking at this triangle as it's oriented, the sine of 30 degrees is 1/2 divided by 1. Well, anything divided by 1 is itself. So, and this is the sine of 30 degrees is 1/2. And this is the utility of the unit circle is that the hypotenuse is going to be the radius of that unit circle is always 1. So the sine is just this side length. The cosine of 30 degrees is the square root of 3 over 2. Divided by 1, of course, but just the square root of 3 over 2. All right, let's look up here. It's this triangle. The sine of 45 degrees is the square root of 2 over 2, opposite divided by hypotenuse, or 1. The square root of 2 over 2 divided by 1 is the square root of 2 over 2. The cosine of 45 degrees is also it's also the square root of 2 over 2 because it's the adjacent side divided by 1. All right. So if I look at this in a little bit different way, I can look at the 30, 60, 90 triangle oriented like so. Put the 60 here, the 30 there. Well, the 1/2 is now here. The square root of 3 over 2 is there, and the 1. Sine of 60, square root of 3 over 2 divided by 1. Cosine 60, 1/2 divided by 1. All right, now this is the background as to how we use the unit circle to find sine and cosine, and all the information is on the unit circle. Okay, let me flip this over, and we'll just draw a small piece of the unit circle. Oh. Okay, let's say that this is the first quadrant of the unit circle. Okay. This circle has radius 1, therefore this point right here is 1, 0. That's 1. This point has to be 0, 1. If this is a unit circle, it has radius of 1. That distance is 1, this distance is 1. All right, I'm going to draw a 30-degree angle right here. Now, constructing this little triangle inside of here. If this is 1, that side is 1/2. This side is square root of 3 over 2. Remember, sine of 30 degrees is 1/2, opposite over hypotenuse. Cosine of 30 degrees is square root of 3 over 2. The coordinates of this point right here, this value is square root of 3 over 2. That is the x-coordinate of that point. The 1/2 is the y-coordinate of that point. So this is why the unit circle is used in trigonometry so much. Any point that's on the unit circle, the coordinates of that point are cosine theta, comma, sine theta. Now that's true for all the points, not just for this one, because I can draw, another triangle here, but the reason we don't draw them all in is because it would get real busy in here and you wouldn't be able to understand anything. But you can see it from this one point. Now, in general, if I take a look at the first quadrant, again, the point 1, 0, 0, 1. Just pick an angle at random and call it theta. If this is still 1, and it is because this is the unit circle, that is the radius, that's the hypotenuse. This distance right here is cosine theta. This distance is sine theta. Now, the reason this is cosine theta is, say I have a coordinate x, y. That distance is x. Well, cosine theta of this angle is equal to x over 1. So x is cosine theta. Similarly, y is sine theta. So this point, you could label it xy, but better, it's labeled cosine theta, comma, sine theta. So the real important point here of the unit circle is that every point on the unit circle has coordinates of cosine theta, sine theta. One thing we should make a note of here is the theta is the central angle, we call it the central angle, where the positive x-axis is the initial side and the terminal side passes through that point. Now, it doesn't have to be in the first quadrant, it could be in any quadrant, as we will soon find out. Okay, let's go to the unit circle. And we'll start filling in some values on the unit circle. Okay, the way the unit circle is oriented is that these angles in here, they're either 30, 45, or 60 degrees. So every one of these lines on the unit circle has a reference angle of either 30, 45, or 60 degrees. All right, we already talked about this one. This is 30 degrees. And I'm going to write 30 degrees right there because it gives us a little symbol. Now, we'll get to what this means here in a second. Okay, we already figured this out. This point is square root of 3 over 2, 1/2. Okay, so what that represents is cosine and sine of 30 degrees. Now, as we do this, we're going to check by graph. Okay. I'm going to check cosine. First of all, I'm going to go to mode and look at this, and I am in degree mode. I had a couple people contact me and say, I'm getting these wrong answers. You're getting such and such on these problems, and I'm getting the wrong answers. Well, it turns out that they were in the wrong mode. every time you pick up the calculator when you are studying trigonometry or doing anything with trigonometry, first thing you do is you look at the mode and make sure you're in the mode that you're supposed to be in. For the time being, we're in degree mode. Everything we do here is going to be in degree mode. Okay, so I am in degree mode, and I'm going to take the cosine of 30 degrees. All right, that's 0.866. Well, what we want to do is make sure that we get this number, 0.866. If I take the square root of 3 divided by 2, that is indeed, oops, I did it wrong because of the math print. Square root of, let me go back. Cosine 30 degrees, I want to get the same numbers on the screen. Okay, then I take the square root of 3 divided by 2. There's my 0.866. Okay, that means that I'm right. Okay, now 45 degrees. Well, I can go back and look at these triangles that I created in order to figure out what 45 degrees is. Okay, cosine is square root of 2 over 2, sine is square root of 2 over 2. Okay, what this means is the cosine of 45 degrees is square root of 2 over 2, and the sine of 45 degrees is square root of 2 over 2. Okay, let's check that out. Cosine 45 degrees, square root of 2 over 2, that's 0.707. We need to confirm that this is square root of 2 divided by 2 is 0.707. Okay, so what you should do is you should write cosine and sine of all of these angles and then check by grapher every time. Okay, well this one's going to be a 60-degree reference angle, so that's 60 degrees. I'm not going to do that for you. All right, I'm going to move over here a little bit. Okay, this reference angle right here is a 60-degree reference angle. Because these, like I said, either 30, 45, or 60-degree reference angle. Okay, so this one's a 60-degree reference angle. Now there's 180 degrees there, so if I take that 60 away, this is 120 degrees. Okay, so we talked about this yesterday. How do I find the sine and the cosine, or well, actually cosine, sine, it comes in that order on the unit circle. Cosine, sine of 120 degrees. Well, we did that by drawing an angle in standard position, 120 degrees. This time, instead of putting the ray out here and a point on it, I'm just going to construct the triangle that I know has a 60-degree reference angle in it. Well, 60 degrees, if it's oriented this way, this side is 1/2, and we're using these triangles for all of what we're doing on the unit circle because they have hypotenuse of 1. 1/2 square root of 3 over 2 and 1. Okay, we know SOHCAHTOA, and we also know this, and I said yesterday, all students take calculus, and what that means is all three sine, cosine, tangent are positive here, sine alone is positive here, tangent alone is positive there, and cosine alone is positive there. So in this quadrant, the sine is positive and the cosine is negative. Only the sine's positive here. Okay, sine, opposite over hypotenuse, so that would be square root of 3 over 2, and that's positive. Cosine, adjacent over hypotenuse, 1/2 over 1. That is negative because it's in the second quadrant. Okay, so I'm going to fill this in. This value is negative 1/2, and that is positive square root of 3 over 2. All right, let's check by grapher. Cosine, 120. Negative 0.5. Perfect. Sine, 120. 0.866. Well, we've already seen that number come up here before, and it was over here, and we saw that the 0.866 was indeed the square root of 3 over 2. So that's right as well. Now, what you find here is that these numbers will come up over and over again. Every one of these values on the unit circle is going to be one of these three numbers. This one, or this one. But they might be positive or negative. And the reason is every one of these angles on the unit circle has a reference angle of 30, 45, or 60. Those numbers come up over and over again. But you should try to write them in before you check by grapher. All right, we have one more thing to cover here. And notice I haven't really talked about these, I wrote these points down, but what do they mean? Okay, this point was 1, 0. Now that we lost our parenthesis there, this one's 0, 1. Well, these angles exist as well. This is 0 degrees. Well, according to what we were talking about here, the cosine of 0 degrees should be that value 1. Here, let's check and see if it is. Cosine 0 is 1. Sine of 0 should be 0. Here, cosine of, this is 90 degrees. Cosine 90, 0, sine 90, 1. Okay, you should verify for yourself what happens here and here. Okay, these points are -1, 0, and 0, -1, and they'll follow the same pattern. Now, there's one thing left for the unit circle, and that's this section on all of these angles. That's the radian equivalent. Okay, we've already converted. This is pi over 6. This one is pi over 4, and we've converted a number of these. You should convert, like here, for example, this one. I'll do this one right here. This is a 30-degree reference angle. That's 150 degrees. Okay. This is how we converted. We took 150 degrees over 1 and multiplied by the conversion factor, which was pi to 180. 150 divided by 180, that reduces, and we have the pi, and you ended up with 5 pi over 6. That's the radian equivalent. So what you should also do is write in here the radian equivalent for all these angles. Okay, 0 degrees is obviously 0 radians. This one down here, if you come all the way around, this is coterminal, so this one 360 degrees, and we've already done this one too. That's 2 pi radians. Okay, so your assignment for today is to fill this in. I will post this document. I also said that you can create your own. If you don't have a printer, you can make your own. It's not that hard. All right, I'll show you. And you may want to get for some extra accuracy. Kind of got some sort of spot there. You can draw a circle. And if you take your time, you can draw a pretty nice circle. And I know all of you, so I don't want to hear anybody telling me that I can't do this, because I know every one of you is perfectly capable of doing it. All right, and you can estimate. Basically, we're going to cut this into thirds. Okay, and then we're going to split this one in half, and this will happen in every quadrant. How long did that take me? I don't know. Half a minute? You can all do that, and you can make all these quadrants. So even if you don't have a printer, you can do this. And we'll go over the answers to this on Monday. But that is your assignment, is to fill in the unit circle. Now, the easier way to do this would be to print that thing off on the shared drive, but if you have to, you make your own. And it's best to make it with a piece of printer paper and not on lined paper. This will work better with a piece of printer paper. But if you use the printer paper, do exactly what we have here. You know, like on the example, there was a little thing here for the 30 degrees, and then there was a little space here for a fraction to make pi over 6, and there was space out here, and you fill those values in. Okay, we'll see you, by the way, it's the weekend coming up, so we'll see you Monday, I guess. Well, I won't see anybody, but I guess I'll talk to you.